Okay, let's get cracking. So this is a little run through of the circles test. What I'd recommend you do is go to the questions you got wrong and listen to the explanations for those. And the idea is obviously to make corrections that you understand on the questions that you need to make understanding for. So our first three are all circle theorems here. So let's just talk through what we should have. CAB is the first angle we need to find. That's this angle here. And we have got an isosceles triangle, and we've also got a triangle inside a semicircle. So this is a right angle, and the other two angles in that triangle have to be the same. So take that away from 180 and divide by 2, and you'll get that they are both 45 degrees. Next up, we have got ECD, which is this angle here, and we're actually going to use alternate segment for that. According to alternate segment, the top right of this triangle should be the same as the bottom left on the tangent, so that's 65 degrees. Lastly, work out the size of BCD. Now BCD is two angles added together, isn't it? It's these two angles combined. And there's a couple of different ways you can get this, but the way that I like is to say, well, these two angles here add up to 110, and that's one side of a cyclic quadrilateral, and this is the other side of the cyclic quadrilateral. So those two angles together will give you 70. So we can go 180, take away 110, it's going to give you 70 degrees. Another way of doing it will be to work out that this angle is 25, as it's part of a right angle triangle with the 65, add that to the 45 and get 70 as well. But cyclic quadrilateral way is neater. Okay, let's move on. So here we need to find what fraction of the shape is shaded. So we have got a diameter of the larger circle 3 times the diameter of the smaller circle. That also means the radius of the larger circle is 3 times the radius of the smaller circle. So I'm just going to call this having a radius of 1 and this having a radius of 3. For the big circle, I just need to do pi times 3 squared, which is 9 pi. For the little circle, I just need to do pi times 1 squared is pi. And so the amount that's actually shaded in is 9 pi, take away pi is 8 pi. Fraction of the shape, 8 pi out of 9 pi, or just 8/9 in its simplest form. I think people tended to undercomplicate this one and just go for 2/3 because of the 3 times thing, but remember, area scale factor, there's some squaring involved. Perimeter of the sector consists of an arc length, which is going around the outside, and to find that we're going to do theta over 360 times pi d, and then it consists of 2 straight sides as well, so it's got a 4 and another 4, so we're going to need to plus 8 when we're done. So let's put that all together. We need to do 285 out of 360 times pi times 8 is our diameter, and then plus 8. Let's just quickly type that one in. And you're going to get yourself an answer of 27.9 centimeters. Again, a few people I think just forgot the perimeter aspect and just found an arc length. Okay, for the construction questions, I'm going to do the best I can without a compass or a ruler and just sort of freehanding it on a tablet. Hopefully I get across what you needed to do. An angle bisector consists of 3 steps. The first one is an arc drawn from B, which touches the lines, which touches both the lines, and we've got like 2 crossing points there. So we've got our crossing point number 1 and our crossing point number 2. So that's step 1. Step 2 is to then draw an arc from each of those 2 red crossing points, and these need to be the same width as each other, but they can be different to the green circle. And step 3 is to join where those 2 cross over with B in a single straight line, and that's your angle bisector. Now please note you are marked not just on have you drawn this accurately, but can the examiner see your construction lines. If the lines that you've drawn are different to what I've got drawn here, you will not get both marks because you haven't constructed an angle bisector, you've just drawn one. Similarly for 7, there are 3 steps. The first step is that we want to draw a circle around P that crosses the line twice. So we'll end up with something like that as our 2 crossing points. In fact, I think if we went, it would be a little bit further. So let's make this look as accurate as we can. Yeah, that's about right. So that's part of a larger circle around P that needs to cross the line twice, and it'll cross it at 2 points. So we've got here and here, and we are going to bisect the line between those 2 points. So from the first point we would get our circle, from the second point we would get our circle, and this is drawn absolutely horrendously, but you should end up with a line that goes through P where those two cross over each other and is at a right angle. Obviously yours will be drawn better than that, but that is the sketch of what I'd need to see on your page. For question 8, we've got O as the centre of a circle, and we want to work out the size of AOC, that's this angle here, and we need to state the circle theorems we use. So the first circle theorem I'm going to use is to get ABC is 62, and the reason for that is that we use a cyclic quadrilateral again, so 180 take away 118 gives you 62, and then my second circle theorem is going to be to say that AOC is 124 because it's a double angle theorem. So in other words, 62 times 2 is going to give me 124 because the angle at the circumference is half the angle at the centre. So 124, that's done, and that's the least you'd have to write, I think, to get it. This semicircle has an area of 30, so that means that the circle that it started with had an area of 60 centimeters squared. So that would be equal to pi r squared, the area of a circle. So if I was to divide by pi, I would get r squared, and if I was to square root that, I would get the radius of the circle. So if I type that in, we get that the radius of that circle is 4.37, but we don't want the radius of the circle, we want y, and y is the diameter of the circle, so we will double that and get that y is 8.74 centimeters. We should include some units. 10, again I'm going to draw this the best I can. What it essentially is going to be is some circles, okay? So we've got a scale that 1 centimeter represents 10 kilometers, so we need a 5 centimeter circle around P. So I think it's going to end up looking something not like that. Let's try and draw that even better. Something like that around P. Not going to be perfect, but you know what I mean. And then we're also going to have a 7 centimeter circle around Q. And those will cross over each other 2 points. Now what we want is the areas of the island with no signal, and that'll be outside both of the circles. So whatever you've drawn, you need to shade outside them both, and you'll have something that looks roughly like that, although yours will be a little bit more accurate. For 11, we've got probably the best thing that we can do on constructions, an equilateral triangle. So that means all the sides are the same length. That means our sides are 4, 4, and 4. So we'll start off by drawing a 4 centimeter line. We'll then take a compass, put the point on one end of the line, stretch it to 4 centimeters in width, and draw an arc that goes from there. We'll then take the same compass, we'll put it at the other end of the line, we'll still have it at 4 centimeters, and we'll end up with our circle around there. And then our final step when we're sketching our triangle is to join up the points to the crossing point to there, and if we've done it right, these will both be 4 centimeters as well. Again, I'm well aware the thing on the screen ain't equilateral, but it's the method that I'm trying to get across. Okay, on to the sectors and arcs. We have got a sector of a circle with the arc length being 25, work out the radius. So the arc length, the formula for that is theta over 360 times pi times d, and we know that's equal to 25. We also know the angle is 70, so 70 over 360 times pi times d is equal to 25. My recommendation would be that you multiply across by 360, which should give you, I think, 9,000 is equal to 70 pi d, and then we'll divide by 70 pi. So we'll get the diameter is 9,000 divided by 70 pi, which will give you that the diameter of this shape is 40.93. However, we want the radius of the shape, it does say, so we're going to need to divide that by 2, and we'll get that the radius is 20.46 centimeters. Okay, your goat is tied up. The rope is 5 meters long, so that means that he can't quite reach the edges of the square, because he's 6 meters away from the edges, and it's only a 5 meter rope. That means that the area he can cover is a semicircle, and the area of the semicircle is going to be equal to a half times pi times r squared. What would that give you? Well, it would give you 0.5 times pi times 5 squared would give you 39.3 meters squared that he can roam in. However, the entire field is a rectangle, as a square rather, and it's a square that has an area of 12 times 12, or 144. If we want to get a percentage of an amount, then we write it as a fraction, and we multiply it up by 100. So that over 144 times 100 will give you that the goat can reach 27.3% of the field. So how long would the rope have to be for the goat to reach the entire field? Now there are two ways of doing this question, and the first way relies on this being an accurate drawing, and I'm not confident that it is, but if you attempted this, I'm probably going to give you the marks because I didn't specifically say diagram not accurately drawn. So one way you could do it is you could just measure the distance from where the goat is to the furthest place he could be. You could find a scale for the diagram if you know that this is 12 meters going along. You could use that to work out what 1 meter is, and you could sort of multiply it up, and we could combine those two things together. However, the way this question is intended to be done is with Pythagoras. We know this distance is 6, we know this distance is 12, and we know that x is the furthest away point from where the goat is. So x squared is 12 squared, add 6 squared is 180. And so we could square root that to get what x actually is, which is going to be 13.4 meters that the rope has to be for him to reach the entire field. If you've come up with a scale model version of getting something in that ballpark, I'll give you the marks. So back to circle theorems. So again, state clearly any circle theorem you use. Our first circle theorem is going to be to get 57 over here. We can say that ECD is equal to 57, and the reason for that is same segment theorem, or bow tie theorem, but we want to say same segment. We can also say that this is 57 as well, because it is an isosceles triangle, and that's how isosceles works. We know it's isosceles because of the lines on the lines. And then lastly, to actually get CDE, we can take those away from 180 and get that it is 66 degrees, and the reason for that is simply that you have a triangle there, and triangles add up to 180 degrees. Then we have a slightly more difficult one. This is a prove that. So we need to show that all of the angles in the shape are equal to 60 degrees, or show that all the side lengths are the same, but we're in circle theorem, so we're going to be talking about angles more likely. So in order, first thing we do is we put some right angles here. We would want to say that OBD is equal to OCD is equal to 90, and the reason for that is tangents and radiuses, or radii, meet at right angles. So that's fine. We're then going to find BOC, and that's going to be 120 degrees, and the reason for that, so BOC is equal to 120 degrees, is that quadrilaterals equal 360 degrees. So if we took away those angles, that's what would be left over. Now, a mistake you could make here is say this because this is a cyclic quadrilateral, and it's not, because D is not on the circumference of the circle and O is inside the circle. A cyclic quadrilateral needs to be entirely on the outside of the shape. From there, we would get a 60-degree angle here, AOC. And the reason for that is that straight lines equal 180. So again, we have to state every rule we use, even if it's the obvious one. And then we can also say that OA and OC are both equal to each other because they are radiuses. And so lastly, we can get the other two angles in that shape to be 60 as well. So therefore, OAC is equal to OCA is equal to 60 degrees, because that is an isosceles triangle. So if you took away the 60 and divided by 2, that's what would be left. So combining those two things together, because we should really finish a proof, it's not enough to just say it. If we put those two facts together, we can get that 3 angles equals 60 degrees, therefore this is an equilateral triangle. And I'm going to stick a proof squared down because I feel like I've earned it with that. Okay, a couple more questions to go. So here we have a sector, and the area of that is 12 pi squared. The formula for area of a sector is theta over 360 times pi times r squared, and that is equal to 12 pi according to this question. However, oh no, we don't know the theta, but we do know the radius, so I can fill in that r is 12. So there we go. Theta over 360 times pi times 12 squared is 12 pi. I would then times across by 360, and I would also square my 12 to get that theta times 144 pi is equal to, I think, 4320 pi. We can divide across, we can get theta is 4320 pi over 144 pi, and that's just going to give you 30 degrees. So we can fill in the angle on that shape. Are we done? No, we need to find the arc length, and the formula for the arc length is going to be theta over 360 times pi d, so times pi times 12, no, not 12, diameter 24 I want to use there. We know that the angle is 30, so we can go ahead and write that in as well, so 30 over 360 times pi times 24, and then that is a 12th times pi times 24, and a 12th of 24 is 2, so that will give you 2 pi. Now if you answered 6.28, that's correct, but it says to give your answer in terms of pi, so you would lose 1 mark for not accurately answering it. Final question is again more constructions. We want to be equidistant from the boneyard and the cabin. Now that means that we have to be the same distance from 2 points, and that's going to be not an angle bisector, it's going to be a line bisector. Same distance from 2 points, line bisector. Same distance from 2 lines will be an angle bisector. So we want the compass more than half the width between these two. We'll join them up where they cross over each other, and we'll end up with a line that our treasure has to be on. The second thing that we need to do is we need to be 50 paces from the palm tree, and this is going to be a 50 pace circle around the palm tree. We'll use this scale to get what 50 paces actually is, and we'll draw a circle around the palm tree, and it will cross over with our line at one point, and that is where your treasure be found. Arr. Cheers.